Namaskaram. In a nutshell, in the 9th issue of Kural deals with a fascinating topic of research, the use of modern machine learning methods to understand traditional classifications of ragas. The work presented in this article has been done by the members of the Comp Music Group of IIT Madras, Professor Hema Murthy, Professor M.V.N. Murthy, Jom Kuriakose, Veena Suresh and Shre Datta. We thank Professor M.V.N. Murthy for writing this article for Kural. This video is just a broad summary of the article. To understand the details and the depth of this work, please do read the article at www.kuralmagazine.in. The Melakarta system, wherein prevalent ragas are classified under various scales, was developed in the 17th century and it was developed by Venkatamakhi. The aim of this work is to understand the basis of this classification and to provide a computational perspective on this classification. The introduction of the article consists of a brief history of treatises in Carnatic music which discuss the concept of ragas and scales, starting right from Bharata's Nati Shastra up until the Sangeeta Ratnakara of Sharangadeva. What is the uniqueness of the Melakarta classification? So as we all know, ragas have many subjective elements. What the Melakarta classification did was to kind of separate these subjective elements from the quantifiable universal elements, and these quantifiable universal elements can be handled computationally, which is what we will be seeing in the rest of the video. I will now provide a basic outline of the Melakarta classification. An octave is divided into 12 pitches or notes, each of which is a simple integer ratio with respect to the tonic or other ashadja. Sa, Ri, Ri, Ga, Ga, Ma, Ma, Pa, Da, Da, Ni, Ni, Sa. These are the 12 pitches. The invariant notes or the achala swaras are sa and pa. There are two varieties of ma, and as for the other notes, Ri 2 is equal to Ga 1, Ga 2 is equal to Ri 3, and the same with Da and Ni. Da 2 is equal to Ni 1 and Ni 2 is equal to Da 3. So, although there are 12 pitches, we have 16 notes in the gamut. These notes which have these pitches which are the same but correspond to two different notes, for example, Ri 2 Ga 1, we will call them as degeneracies. Some definitions. A primary scale is one which has the 7 notes Sari Gama Pada Ni in a symmetric order. The number of such primary scales are 72, and you can find the calculation in the slide. The symbol C, for example 4C2, denotes combination, the number of ways of choosing 2 elements from 4 elements. There are 4 possible choices of Riga and Dhani each, and as said before, 2 possible choices of Ma. Now these are the 72 Melakarta ragas. Given a particular raga, if its notes form a subset of the notes of a particular scale, it is said to be derived from that scale or that Melakarta raga. A raga with 7 distinct notes in the ascending and or the descending order has just one unique parent. This is obvious. A raga with 6 notes has a maximum of up to 3 parents depending on which note is missing. For example, if the note pa is missing, then the raga has a unique parent since pa has only one choice. I mean, it is an achala swara. A raga with 5 notes has the number of parents of a raga with 5 notes could be 2, 3, 4, 6, 9, again depending on which are the missing notes. Although these are the objective possibilities, almost every raga which is prevalent today is assigned to a unique parent, and this has happened over 4 centuries of evolution of our music. But not all these assignments are readily accepted. Now the question is, how has this Melakarta system, classification system, evolved into such a sophisticated framework of classification, given that ragas have so many subjective and qualitative features? A semi-quantitative basis for Melakarta classification. Computational music technology is a method which combines developments in musical acoustics along with technological advances combined with a very deep-rooted understanding of the system of music under consideration, leading to music information retrieval and analysis. This method is now used to critically analyze Venkatamakhi's classification. The first aim is to represent a raga computationally. So how can we do this? A raga is represented as a probability distribution with a weight or likelihood attached to each of the 12 notes in the octave. The weight of each note is determined by the number of times the performer accesses that particular note, and this is the quantity Ni. All the octaves are folded back into a single octave. Now, something called a pitch histogram is formed. A pitch histogram is a histogram of all the pitches which occur in an audio sample of a raga. Now let us look at the pitch histogram of a very common raga, Mohanam, which has 5 notes. Sa re ga pa da sa, sa da pa ga re sa. So this is Mohanam. And as you can see from the figure, the tonic sa has the highest frequency of occurrence, and this is followed by the other notes. Now, even the notes which are not actually present in the raga never have a probability of 0 or a likelihood of 0. This is because the movement of a raga from one note to another is always continuous, so that probability can never technically be 0. According to the Venkatamakhi classification, Mohanam can have 4 possible parents: Harikamboji, Kalyani, Shankaravarnam and Vachaspati. Now, using the same pitch histogram methods for these 4 parents and superposing the pitch histogram of Mohanam on each of these 4 parents, we see that we can rule out Vachaspati pretty quickly. But then how do we choose from among the rest? Compositions as basic data. A raga can be represented as a point in a 12-dimensional space. Usually, a raga resides in a 7-dimensional subspace of such a 12-dimensional space. The distance between 2 ragas in such a subspace can be measured by what is called a Euclidean distance. Here Pi and Qi represent the 2 points representing 2 ragas. Although this is the simplest method, it is not the best. So here 4 other distance measures are compared in order to see which is the closest parent to Mohanam. All these measures show that Kalyani is the closest parent to Mohanam. But in the Euclidean measure, it is seen that Kalyani is followed by Shankaravarnam rather than Harikamboji. But in Venkatamakhi's standard classification, Harikamboji is given as the parent of Mohana. The methodology is now fine-tuned by looking at the pallavis of various compositions rather than entire compositions. The main reason for doing that is the insight that the pallavi of a composition essentially defines a raga. So when we do the same pitch histogram method, looking at only the pallavi of compositions, and we try to find the closest parent to Mohanam among Harikamboji, Shankarabharanam and Kalyani, we see a better difference among the ragas, and also we see that Kalyani is the closest parent to Mohanam, thus confirming the earlier result that has been obtained. Now a big question arises. So representing a raga as the probability distribution of frequencies using this pitch histogram method essentially takes into account the integrated effects of all the nuances and features of a raga. But now can we go one step further and see if we can actually look at the nuances of a raga itself in order to compare with other ragas and discover its kinship with other ragas. So this is what the longest common segment set LCSS method does. It essentially matches motifs between any two melodic outlines. So in this figure, the x-axis shows a melodic outline, a melodic phrase in Raga Mohana, while the y-axis has the melodic phrase of a likely parent. Now, if these two phrases are exactly the same, then we get a straight line along the diagonal. The measure of closeness is the deviation from this diagonal. Depending on the closeness, we assign a score which is shown on the top of each of the LCSS graphs. If the melodic outlines are exactly the same, the highest score is equal to 1. While if there is no correlation between the melodic outlines, the score is 0. Now averaging over a lot of these melodic outlines in both the ragas, both Mohanam and the ragas that we compare it to, we get a statistically significant score. Using this method, it is seen that Mohanam is actually closer to Harikamboji, which captures the spirit of the traditional classification system, the Venkatamakhi classification system. This table compares the three methods discussed here along with the traditional classifications for various other ragas. We see that even in the case of Audava ragas, the LCSS method captures the spirit of the Venkatamakhi classification much better than the other two methods. We are really honored and happy to have featured this amazing research work in Kural. For me personally, it has been an eye-opener to have read about this research work and also to have discussed with Professor Murthy. To listen to him talk on this topic, please click on the link in the description below. Hope you enjoyed this session. Thank you.